Number 56. The rate of a certain reaction doubles for every 10 degrees rise in temperature. Letter B. How much faster does the reaction proceed at 95 degrees Celsius than at 25 degrees Celsius? Okay, so we basically just have to see what happens when we increase the temperature from 25 to 95. How much faster is that rate going to be? So it seems like we have a starting temperature of 25 degrees Celsius and we have an ending temperature of 95 degrees Celsius. And according to the parameters of this reaction, they say that the rate will double. So if you double something, that means that it goes up 2 times, and it's going to increase, it's going to go up by 2 times that rate for every 10 degrees rise in the temperature. So you're going to double the rate by going up 10 degrees Celsius. So we're just going to make up a scenario. Seems like we have 2 parameters here, right? We're going to be talking about temperature, and we're going to be talking about the rate, the reaction rate, if you want to say it. So we'll say reaction rate. Okay. So start off with any reaction rate that you want, but we have to start off with the temperature that they gave us. We're going to start at 25 and we're going to try to end at, we're not going to try, we're definitely going to end at 95. So we have 25 degrees Celsius, and doesn't matter what reaction rate you start off with. 1, 2, 3, 4, doesn't matter to me. I always just like to start off with 1 because it just makes life easy. And I'm using the molarity per second unit for rate. Doesn't really matter what units you use. The number is way more important here. So now, abiding by the rules of this reaction, that rate is going to double every 10 degrees rise. So we just have to go 10 degrees out at a time. So we'll reach the first 10 degrees. 25 plus 10 degrees Celsius is 35 degrees Celsius. And for every 10 degrees increase, you're going to double that rate, so we're going to times it by 2. And now 1 molarity per second turns into 2 molarity per second. I'm not at the 95 yet, so I just got to keep going. So 35 now turns into plus 10 degrees Celsius. That turns into 45 degrees Celsius. And we have to double the rate as well, so times it by 2. 2 times 2 is now 4 molarity per second. Not there to 95 yet, so we just got to keep going. 45 with a 10 degree increase is 55 degrees Celsius. And since we increased by 10, we got to double that rate. 4 times 2 is 8 molarity per second. Oh boy, this thing's getting fast. 55, we got to keep going, right? Because we got to get to 95. So 65 is next because we added 10. And because of that, we added another 10. It increases by 2. It doubles. So 8 times 2 is now 16 molarity per second. Oh boy, we're almost there. Let's see. Can I maybe move this a little bit this way? Let's pull this back. Let's see, maybe I can get a little bit more room. Okay. So now let's see if that affords me anything. 65. We're going to plus 10. That turns into 75. And we got to double that rate. So 16 times 2 is 32 molarity per second. Whoa. Keep going. I don't like that. I like the arrows. We'll do one more here, and then we'll do the last one on the bottom. Can I fit it? Maybe? I don't think so. But anyway, we'll keep going. So we got now 85 degrees Celsius. That's a plus 10. And now 32, got to double it. 32 times 32 is 64 molarity per second. So now I'm just going to backtrack. I'm going to go up. So we'll go up and then we'll go down. So we're almost there. Plus 10 degrees Celsius, that's the 95. So we reached our max temperature, which means that whatever this is, that's going to be the answer. So it's going to double. times by 2. Christina, let's see. Can we do the math together? 64 times 2, 128? 128 molarity per second. So now, this is why I love to start with 1, because generally, if you didn't start at number 1, maybe you started off at 2. What you would have to do is to find out the actual how much faster it is, you have to take your final rate, which is 128 in my case, molarity per second, and divide it by your initial rate. In my case, it's 1. And I know that anything divided by 1 is the answer. So I don't really have to do that one last step at the end because I know whatever this is going to be the answer. But how much faster does the rate proceed? It proceeds at 128 times faster. That's crazy. That's why if you kind of like the idea where like you save a penny a day and then you double it, right? You double a penny every day. Compound. It's a beautiful thing. So, yeah. So the change in the temperature is much different from the change in the actual rate. So how much faster does the reaction proceed? It proceeds 128 times faster. Wowsies. And that's it. I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I look forward to helping you in more questions. Thanks for hanging out. Keep studying hard. Always keep learning. And I hope these videos are helping you out, all right? I want you to do really well on those tests and quizzes, and I'll talk to you soon. Okay, bye-bye.